Hey all dear students, let's see this question of electrostatics from Pathfinder. Build up your understanding. Question number 18. Question is saying an insulating hollow cube of side L carries a uniform charge on all its surfaces. The surface charge density is sigma. Determine the force acting on a face due to all other faces. That's a very good question. So to proceed for solving this question, I'll use first result, and that result is, suppose if I have some charge surface charge here on any arbitrary shape. Suppose the surface charge density is uniform everywhere, that is sigma, and the flux through this surface is say phi. The flux crossing through the surface is phi, and if the flux is crossing, it means some electric field is there, electric field is present in a space. So electric field is present, and this is a charge here, surface charge is there, so obviously there must be force. I want to calculate the force on this plate whose surface charge density is sigma, and the flux crossing through is phi, and the result is that the perpendicular component of the force perpendicular surface is given by sigma into total flux crossing through that surface. So let me quickly explain how this will come. So suppose if I take a very small part of this surface whose area is dA, this is a dA vector, and the charge on this part would be obviously dq would be a sigma dA. Local electric field here is at different point would be different, but on this point suppose the local electric field is E, making an angle theta with the area vector or the normal. So force on this little part dF would be obviously along the electric field, so that dF would be how much? dF would be dq into that local electric field there. dq is a sigma dA, and this is E. So what we are interested in, the normal component of this force. So on this part, the normal component of the force is dF perpendicular would be a dF cos theta. So dF cos theta is a sigma E cos theta into dA. So similarly for the all the such elements, the net force component, net force normal to the surface would be the integration of dF perpendicular, and that would be the sigma E cos theta into dA. And the sigma is constant on the opposite surface S. Sigma is constant, can be taken outside the integral. So this and this thing is nothing but E dot dA on S, and that E dot dA on S is nothing but the flux crossing through that surface. So F perpendicular is sigma into phi. That's what I will use. That is the normal component of the force. So now we have an insulating hollow cube of length L. So let me draw that. So here I have to find the force acting on one face due to all other faces. So what I need to do, I need to find the flux through this face due to all other faces. So for that thing, let me find the flux through all the cube. Just take a imaginary Gaussian surface that is containing all these charges just outside. So total flux through all the 6 faces, phi total would be q total divided by epsilon naught. And if I write the charge of the one face, say q, and that q is simply sigma into L square. There are 6 faces, total flux is 6q divided by epsilon naught. So total flux through one face, that phi on one face, phi total, this is a total flux through all the cube. So on through single phase, the total flux is 1/6 of this total flux, that is a q by epsilon naught. But on this flux, there is a contribution of its own charge. But here we have to find the force acting on one face due to all other faces. So for that thing, let's take one single face like the shaded one here on this page. So if that is this face, I'm just seeing from the front. So this is one plate charge q. The field lines through this would be like this, like this, like this, like this, like this, like this. If I take a Gaussian surface that just outside this plate like this, so total flux through this Gaussian surface is simply q by epsilon naught. And symmetry of the situation is that saying that the out of the total flux, half of should go on this side and half go should on that side. So this flux here, that should be phi dash is equal to q by 2 epsilon naught. That is the flux crossing here on this side. So coming back here on this phase, the total flux crossing is q by epsilon naught. And because in this q by epsilon naught there is a contribution of all the 6 phases including its own contribution. So because of this phase, q by 2 epsilon naught is going this way and q by 2 epsilon naught is going this way. So on this part which is going outside, the contribution of this phase is q by 2 epsilon naught. So I can write the flux on this one single phase to all the other 5 phases is q total minus flux due to this phase on the outside direction. So total flux through one phase due to other 5 phases is a q by epsilon naught minus q by 2 epsilon naught, which is q by 2 epsilon naught. Now I can straightforward apply this result, and the symmetry of the situation is that the f net has to be perpendicular to the surface, and that f net will be f perpendicular only. So f net is f perpendicular only. So net force acting on this plate is F, and that is equal to sigma into flux due to all other phases, which I have got q by 2 epsilon naught, and put the value of q is equal to sigma L square. So that will be sigma L square divided by 2 epsilon naught. That is our answer. Thank you.